So last time we talked about variables. Okay. So you can create a variable just by giving it a name and an assignment operator, and then some object. Okay, so you can say something like A equals 1, 2, 3. And you have created a variable. And if you ask Python to tell you what A is, it'll report out to you using the REPL, the read, execute, print loop. Or if you want to, you can print it and get to that information another way. As you saw, sometimes when we have strings, particularly triple quoted strings, the print and the REPL can yield different results. Now we can demonstrate that one more time by saying a string. And these are terrible variable names. I'm just doing it to spare you having to watch me type and make a lot of mistakes. So if we wanted to put a string inside triple quotes, we could say Quinn, the husky. That's who I just got out of the rain with. Okay. And that'll be sufficient to meet this criteria. We've created a name and we've associated it with an object. We can ask it to just report on the string, and it'll show the new line characters in there. If we ask it to print the string, it will read the new line characters and take them just as we meant them. So you've got a couple different ways of getting variables out of Python. What kind of variable do you have? Well, you can usually eyeball what the REPL gives you. This one is surrounded by quotes, so you can be pretty sure it's a string. If you're not sure, you can always ask. So you can ask Python, hey, what type is this S variable? And it'll go ahead and tell you. And the string is a Python object. And if you ever wonder if Python knows about something, like you're wondering what to name a variable, you can just type in a word like string, and Python knows what that is already. And if Python knows about it, you can always type help against it if you want to learn a lot more about it. This is additional confirmation that Python knows about it, but we don't have to do that right now. So we've got strings, we've got integers. Python knows about a floating point number. As long as you put this decimal in here, Python will infer that we really have a floating point number. And if we're not sure, we can ask. And sure enough, it'll tell us it's a floating point number. We talked about complex numbers. And you can make a complex number out of a real component. And then you can use a plus or a minus sign and hook it up to an imaginary component. You get a complex number out of that. Okay, so we've got floating points and integers as our two main types of numbers. We've also got complex numbers as another main type of number. I showed you yesterday that there's a few exotic ones, like there's a decimal library. So you can import decimal, or you can import fractions if you need accurate numbers. Floating points, you recall, aren't that accurate. They're as accurate as they can be in the space available, but if we want to get a number, Python and your computer will do the best job possible of representing it. It can always represent an integer well, but if we're going from a base 10 number to a base 2 number, and the base 2 is the only kind of numbers the computer can really think about, Sometimes it's a bit of a force fit and it won't be perfect. That being said, it's going to be close enough for most of what you need, and Python will help you out if you really need to do better than that. Okay, we learned that there's a Boolean kind of a number, and we can say true or false. And if we give it either true or false, I'll put a comment here to show you true. And note both true and false are capitalized. That's kind of weird. Most stuff in Python isn't. But true or false is going to take on some kind of a Boolean value. And if we ask what type we just made, it'll go ahead and tell us it's a Boolean value. Okay, so the Boolean values handle, all the logical choices. So if we wanted to ask if 1, 2, 3 is the same as 1, 2, 3, we've asked a question. We've said, are you the same? It's going to evaluate that as a true or a false. Okay, so we can handle truth tables and truth statements with this. Most kinds of numbers with floating points and integers. Weird kind of numbers with complex. We need to get into two orthogonal planes of analysis, and really accurate ones with fraction and decimal. And the last thing we covered that you need to know and kind of have some facility with is the notion that you can change variable types from one to the other. So if we wanted to reuse A, and that's going to be a float, and then we can say B is 6, 7, 8. That's going to be an integer. A lot of times you can use some kind of a verb to do typecasting, which is just fancy for changing the kind of variable. So if you wanted to make B into a floating point number, you could do that by saying float B. So that'll use the variable type as a verb or as a method and do its best to make that conversion. You could say a float on a string. Like, let's say you had a string that said 1, 2, 3. Or how about 1.234? It'll work just as well. Well, float, the method, is going to do its best job to try to figure out what you mean. Okay. If you wanted to do a float, let's make x equals 1.0, and then you asked for an integer value using that as an input, it'll still do okay. So a lot of times you can just really easily do a conversion of one thing to another. It won't always work though. And if it doesn't, Python will yell at you. It's not a big deal. But it's just sometimes Python doesn't know what the hell you mean. So if we wanted to make an integer out of A, and A is 1.23, what's it going to do? Well, we can ask. So it truncates. That might not be what we want it to do. We can say make an integer out of the string 1.234, and it'll try its best, but it can't always do it. Okay, it just fails. All right. Now, 1.234, we can do something with it. We saw that. And if you really want to do something like this and you have a problem, you can nest these things. So you can do things like nest or chain operations together. sometimes. And you can just try it and see if you break it. So let's just say our string is going to be 1.234. Well, we know we can make an integer out of it. Integer out of S. Oh, no, we can't. Well, we can make a float out of S. Oh, there we go. That works. Now, if we wanted to convert this into an integer, all we really have to do is call integer on the result of float S, which you can see right down here. And it will do its best job to convert it into an integer. So sometimes you got to play with it a little bit to get what you want. But I will say, when you're first learning Python, you want to do what you can to know what Python is going to do. Okay. Now, you might or might not expect that if you said, try to convert 1.234 into an integer, you might expect something different. Okay, so just, have a quick look and be sure. You can't break it. It won't take a lot of time, but just conduct your own little experiments to make sure that Python is working as you expect. It'll work as it works, for sure. And it'll work as documented 99.99999% of the time, but might not work like you think. Okay, so those are the important things. We've got a few variable types. Right, we've got floating points and integers and complex numbers. We've got exotic number types if we need them. We've got strings, and we've got Boolean values. And with that repertoire of objects, you can do anything in the world. As time goes on, we'll be looking at collections of objects. So like lists of floating point numbers and that kind of thing. And if you get into data science, you might be dealing with even fancier lists of numbers that'll be wrapped up in some kind of other object to make them easier to use. But right now, you know all the objects you really need to do most anything you want to do in Python. So good job so far. Now, does anybody have questions at this point? No? Okay. So we will delve into today's lesson. And I'll make a markdown page here. And this is, we'll call it lesson 3. And what we're talking about today, let me grab something here. This class, or this lesson is entitled, come on, you can do it. There we go. Simple operations. And we really mean it. I'm not going to throw a lot of terrible stuff at you, but it's just stuff you can do with the building blocks you already have. Okay. So we'll talk about some arithmetic operations. And we've talked about those, right? We've seen how the plus and the minus and the star work for multiplication. I've shown you how the plus operation works a little differently for strings than it does for integers, say. But we'll go through a bunch of that. We'll talk about cool things you can do with the print function. And we'll talk a little bit more about strings and talk about escape sequences within strings. Okay. And this slide will show you kind of the first topic. It's the various arithmetic operations you can do just with basic Python. All right. Let's get this out of here. And we'll call this basic ops, and we'll call this arithmetic operators. Okay, now that should have looked a lot better, and that's because I wanted a markdown cell. There we go. There we go. So let's get a couple of variables. Let's call them A, and let's call this 12, and B, let's call this 10. Just some easy numbers. We can play with more if we want. So we've got addition, and addition is just going to use the plus, like so. Okay, now addition is going to be done under the hood by the add method of any class. All right, and I don't want to belabor on this, but the classes in Python are kind of fully self-supporting, kind of like an army unit might be, or a Boy Scout troop, or they know how to do all kinds of stuff. And the work of an operator like a plus sign isn't tied to the plus sign itself. Okay, to Python, the plus sign has no meaning, and the minus sign has no inherent meaning. But it's tied to some kind of method in a class. And the plus sign happens to be tied to add. But if you have an object, you can define what you mean by a plus sign. And you can tell that object to react in any way you want it to. All right. Well, we can also do subtraction. And that's the under sub operator under the hood. Okay, and that is implemented with the minus sign. So there's also kind of related to that is called it's got a funny name, unary minus, and that is just a fancy way of saying fancy for applying to a single value. Okay, so you can say A like so, and then you can say minus A like so. Whoop, minus A like so. Okay. So I'm just going to get rid of this. We know what A is, so I'll just say minus A here, so your notes will be a little bit cleaner. All right. Python will also deal with multiplication. Okay, and that's the underscore mul operator under the hood, and that's a star. So we can say A times B. So pretty straightforward. We can do a division. And this is straight up division. Some people call it, I don't know why, a float division. But that just means straight up. Normal division. And that's done by the div operator under the hood. And it's implemented by a slash. So you can say A divided by B, like so. Now, if you said 120 divided by 10, you would get this. And I think maybe this is where the float division term comes, because even if you divide two numbers and you come up with something that could be an integer, you'll come up with a floating point. Okay, now this is kind of important. In Python 2, and you'll still see plenty of Python 2 out there in the world, this operator did floor division. Okay, and plenty of people have gotten messed up on that. Now in Python 3, floor division is implemented by floor, and it behaves just like the slash did in Python 2. Okay, and that's implemented by 2 slashes. So let's go A//B. Okay, so what you get is the, well, let's actually here, let's print A, and then A, and then B, and then B, and then a single slash, and then an A/B, and then a double slash, and say A/B. All right, so A and B are 10 and 12. If we do a slash, we're going to get 1.2, okay, which will be exact, or as exact as a floating point can be. If we do a floor division operation, we just get the round number. Okay, we just get the 1 out of it. So it truncates it. It doesn't try to round it or anything. It'll just truncate it. Okay, so you need to be a little bit careful if you use this or see it or work with Python 2. All right, now related to that, yeah.
Quick question. Let's say we have 1.5 or 6. The roundup is gonna be 2 or is gonna stay 1?
So the question is, if you have Python 1.5, how does it work?
Yes, 1.5. Is there any differences between 1.5, 1.6, 1.7? By the way, this is the second question.
Oh, okay. Yeah, there are differences. The biggest division is Python 2.7 is the last stable version of the old Python. Okay, and then it went to Python 3. Right now, there's a whole bunch of things different between Python 2 and Python 3. Now, Python 2 and earlier versions than that were pretty close to the same. Not completely. They threw in different enhancements over time. But then they switched to Python 3.0. And all the Python 3 versions are real close to each other with a few improvements.
Pat, I'm sorry. Maybe you got my question. I couldn't actually explain my question correctly. My question is not the Python 2.7. My question is, let's say we get the print 1.2, right? You said the floor division is gonna be round up, right? To 1. 1.1 is gonna be round up to 1, right?
That's right. Yeah.
Okay. So my question is, we get 1.5. So round up is gonna be 2, or what's gonna be for the floor division?
We can just find out. We can divide it by 1, and no, it doesn't round. In fact, we can go 1.999 and do a floor division, and we'll still get 1. Okay, so here's let me get to one more topic here, and it might make sense. There's something called a modulus or modulo operator, and that's run by the mod method, and that's implemented with a percent sign. So let's ask for print A and B Okay, and then say A percent B. Okay, so if we take A modulo B, what we're asking for is the remainder after a floor division. Okay, so if we said print A floor division B and A modulo B, and then whoop. Okay, and then we added those two together. So A floor division B plus A modulus B. Oop, hang on. That's not what I was trying to show you. Okay, so we get 2 and we get 1. So if we said 1 times 10 plus 2 gets us our original number. Okay, so the whole number of things we can divide. So we can divide 110 and we have 2 left over. So let me do this another way. Let's say floor equals A div B. Okay, and if we say mod result is A percent B. Okay, so now if we say floor times A plus B, we'll get the original back out of it. Or we should. Floor times A. Oh, I'm sorry. Floor times B plus B. Is that right? Plus A. Oh, geez, I'm screwing this up. So our floor is 1, and we multiply it by A. Okay, so we multiply it by the A minus floor times B. I think that is going to work. And then we'll have to add to it. Yeah. And then we can say plus mod. Okay, so the point I'm trying to make, and I'm making it rather in a clumsy way, I'm so sorry. But this gives you the remainder. Okay, and this gives you the whole number. So let's do another one. If we said 101, how many hundreds are in there? Whole 100s. There's going to be 1. Okay, so this is going to tell us 1. Okay, if we say 101 modulus 100, it's going to also give us 1. So this is telling us if we do 101 divided by 100, we have 1 100s. And this tells you the remainder is 2. Now, if we made it 103, we're still going to have a single 100 dividing evenly. But here, we're going to have 3 left over. Okay, if we have 120 divided by 100, we can only take 1 100 away from it, and we'll have 20 left over. You see how that works? Now, a use case for modulo is figuring out whether you have an even or an odd number. Okay. All right. So if you have an even number, 4, you can ask whether you can divide 4 evenly by 2. Okay. And 2 divides evenly into 4, so there's no remainder. All right, so if you had a collection, you could say for test in, and let's give it a tuple of numbers, and let's say 2, 3, 4, 5. You saw this yesterday, right? We used the keyword for. And this is just some arbitrary looping variable in some iterable with a colon. And then we can do something underneath it. We have to indent it. So we can say print, we can say if test modulo 2 is 0, print even. All right, so it's gonna grab the 2 first time around. It's gonna go 2 modulo 2, and it's going to divide evenly, so there's no remainder. If there's no remainder, it'll print, hey, it's even. The next time through, it's going to take this 3, and it's going to divide 3 by 2, and the remainder will be 1. So it'll fail this test. So it won't do anything. It'll come and grab 4, it'll divide by 2, it'll have no remainder, and it will tell us that it's even. And of course, 5 is an odd number. So if we run that, we learn what our even numbers are rather. So most of the time I've seen modulo used is in a loop like this, where we're testing for, we want every 10th number or every 100th number or every 3rd number or something like that. You can do that easily by testing the remainder after division. All right, does that make sense? Okay, and the last mainline operation is exponentiation. Okay, and that is done by the exp method, and that's implemented by 2 stars. So if we say A, 2 stars B, this is going to give us A raised to the B power. So let's make slightly easier numbers. Let's say C is 8. Let's say C is 2. Okay. And D is 8. This is a real common sort of thing you want to do with computers. Most everything in a computer, it's sized to be 2 raised to the something power. So if you wondered what 2 to the 8th is, you could say C to the D. And that should give you 2 times 2 times 2 times 2 times 2 times 2 times 2, which I think is 256. Yeah, there it is. Okay. Questions about that so far? Okay. here's a little quiz. Let's see if you guys, without typing anything, can figure out what these will yield. So just think about it in your head. So if you print and the expression you print is 11 minus 7, what are you going to come up with? And if you print an integer plus a floating point, what are you going to come up with? Right? And what about this? You're going to print out a string. And here you're going to print out a string, and you're going to use the plus operator against an integer. So these are 4 real different cases. So I'll give you a minute to ponder that, and then I'll show you and explain why we get what we get. Okay, I'm going to set this aside. And we'll make another markdown cell. So, okay. Now the first one we had is print, what was it, 11 minus 7. Okay, now I actually haven't tested these before. I think I have an idea of what they're going to do and why. But I'll explain my reasoning and you can see how wrong I am. So I'm seeing we've got a valid operation, right? We can subtract 2 integers from each other. And in fact, I'm going to split this cell here and just play with it on the side. So if we say 11 minus 7, I think that's going to yield an integer because Python tries to produce the same kind of number that it was given, if at all possible. So I think this is going to print 4. And the integer version of 4, right? But if it prints something, it has to print a string. So I think what it's really going to do is print a string version of 11 minus 7. And if I do that, we're going to get 4 with quotes around it. Okay. Now, I don't think it'll put quotes around it, but I think what'll come out will be a string. Let's see what happens. Yeah, okay. So it printed something, right? It printed a string 4, but it didn't put quotes around it. But it did the math for us. That's pretty cool. All right, now how about print, and we'll say 4 plus 11.0. So I'm looking at this and I'm pretty sure we can do this. I mean, if Python can't add these 2 numbers, it's pretty dumb. So it's going to do it, but I think it's going to take note of the fact there's a decimal point here, and it's going to infer this is a floating point number. Okay, and then it's going to add another number to it that's an integer. Now, it can't, or it won't make both these integers, I don't think, right? Because when we divided an integer by an integer, it returned a floating point, right? So I think its floating point is its go-to if it can't figure anything else. So I'm going to guess this is going to print a floating point number of 15.0. Yes, yes. Okay. So when you combine 2 numbers, and you care, you know, if it matters to you, it's a really good idea to find out what kind of number is produced by Python. Okay, you can see its go-to its go-to value is an integer. You might well not want an integer if you're actually doing that operation. right? So if you were just doing an operation in the wild and you wanted to go 4 plus 11.0, and you know both those are going to be integers, you might well want to do a type conversion like so and make sure. Now, if you tried to do things that maybe didn't make sense in that context, you'd want to be a little bit careful because Python may or may not do what you expect with that. All righty, what next? We've got next print 11 minus 7. Okay, now that looks like a valid operation to me, right? Just like this. It's got extra spaces. But I don't think it's going to treat that like math. I think it's going to say this is a string, and the fact it happens to have some numbers and a minus symbol in there is kind of irrelevant, because to Python, you can have a character like that, or a character like this, or a character like that, or a character like that, or a blank space, or a character like that, and they're all just characters. So I think this is going to be interpreted as character string, and Python will just echo it. Let's see what it does. Yeah. Okay. And the last one it did, last one we're looking at is here is print. And this is going to be 4 as a string plus 4. What do you think is going to go down here? I think Python is going to throw up on my shoes. And the reason is that this addition, the plus sign, this is defined in the add method of the integer, and it's defined in the add method of the string. And it's not going to be defined. An integer isn't going to say, oh, okay, I'm going to figure out what to do if you try to add a string to me. It's not going there, because if you're doing that, you've probably screwed it up. And I think the same thing with the string. It's like saying, what do I know of adding numbers? Yeah, ask me to do trigonometry too, will you? So I think this is going to end up with an error, and probably a type error, because we're trying to cram 2 disparate types together. Let's see. Yes, type error. Okay. And it's going to yell at you pretty specifically. And just to slightly belabor a point, you can say the string 4 plus the string 4, and you'll have a concatenation operation. And you can say a number 4 plus a number 4, and you'll have arithmetic. It's just when you start trying to mix them together, Python just gives up and says, dude, get it straight and come back and we'll work with you. Okay, so we're about ready to go for a break. I'll tell you what, I'll field any questions you might have about this so far when we get back, and I'll see you at the top of the hour. All right.
Before you go, can you scroll up to the for loop, please?
Yeah, tell me when to stop. Oh, the for loop, yeah.
Perfect, thank you.
Yeah, sure. And in fact, if you want to play with it, I will paste it into the Slack channel, and you don't have to type it. This is going to go into class chat. There we go. Oh, hey, I just noticed something, guys. I put the notebook from last class in class chat at the end of class, and I didn't hit return on Slack. So you never got it. I just sent it in there now. All right, guys, welcome back. So before we get going, does anybody have any questions? I see what looks like a hand icon in Tino Tenda's little box here. Was there a question? I might be butchering Tino Tenda's name. Okay, no questions? All right, well, feel free to.
No questions. That was an error. My apologies.
Hey, no worries. I hope I didn't butcher your name. Sorry if I did.
You pronounced it perfect. Thank you.
Yeah. All right. So let's get back to our screen sharing mode. Yes.
This is Joshua. I
Joshua,
saw
hi.
some of our students wanted you to share your Jupyter notes, if it's possible.
Yeah. Okay. When I was when I pasted a little bit of code into the class chat before break, and I noticed that I had pasted in last session's notebook, but I didn't hit send. Anyway, I've done that. So it's going to be in the class chat.
Okay. Thanks.
Yeah, sure.
And also, if it's possible, at the end of this session, if you will share these sessions notes, it would be perfect.
Absolutely. Absolutely.
Okay,
In fact,
thanks.
I'm trying to make the notes nice so you guys can actually use them.
Okay, thanks.
Sure. All right, so here's an application. Here's a question for you. Can you figure out the area of a circle with a radius of 5? I got to tell you, my wife has horses, right? We've got a couple of easy to ride gated horses, and she subscribes to a horse magazine that's written by horse ladies for horse ladies. And they had this 5-page article on how to make a round circle. I kid you not, how to make a round circle. And it went through elaborate details about you walk 10 paces in this direction, and then you walk 10 paces in another direction from the same point, and so on. And oh my God, 5 pages. Oh, but she's not here, so I can actually complain about it. But the area of a circle is the radius squared times pi. Okay, and pi is about 3.14156, and it goes on forever. So see if you can, in your own environment, figure out what the diameter is if the radius is equal to 5. And I'll give you a couple minutes to do that. Anybody need more time? Okay, there's actually, a couple of, a few different solutions to it. You might want to get a value for pi. You might want to make pi a variable. And that's what I would do. Just because if I want to calculate a different area for a different circle, I would already have this in my namespace. Like so. And then I would probably make another variable for my radius. Like so. And then I would use a good variable name like area, and that's going to be pi r squared. So one way I could do it is say pi times r, right? And then I can print my area like so. But I might look at this and say, you know what, I can be a little more clever, because Python has a power operator. So I might be able to get to the same answer by saying pi times r and using 2 stars to raise r to the 2nd power, which is the same as r times r, isn't it? And with any luck, I'll get the same answer. Yeah, I did. Okay, now here's something else you should know. This is a little off script, but not too much. Python has a bunch of libraries. There's thousands and thousands of them. But there's some pretty commonly used ones. And if you have something really common, like you need to know the value of pi, well, there's probably a Python library for it. In fact, there's a library called math, and you can get to it by saying import math, like so. And if you do that, math has all kinds of cool stuff. So you can find out what's in math's namespace by just using a directory against it. And if you want to see it a little more succinctly, this is already a list, right? But if you want to print that, it'll show up a little better in a notebook. So it's got all kinds of stuff, right? So it's got cosine, hyperbolic cosine, it's got degrees, and it's got rad here somewhere, so you can convert between radians and degree metrics. It knows how to do logs of any base. Okay, so it knows how to do a lot of stuff. So if you're ever needing to do something math related, you can probably find it in the math library. And once you've imported it, you can ask it for math. And because it's in a library, Python doesn't know about it by its first name. You can't just say pi. But if you say, okay, within the math library, and I'm going to put a dot here, find the name pi in that library. And it'll tell you what pi is. I got it pretty close here. 1.14592. Oh, okay, I missed this. This should be 9. You know, but I can't remember. It's like, God, you know, 3.14 is close enough for most things. And, you know, really for the kind of construction I do with chainsaws, I usually just have to remember that it's around 3. But I can't remember this. And nobody would expect anybody else to either. That's why it's part of the library. So my final upgrade might be to remember or believe that there's pi out there already in the Python world, and say pi equals, I'll make a local copy of that name. And heck, I don't even have to do that if I don't want to. I could just say math times math.pi, and I could use the power operator against the radius. And that should give us real close to the same answer. Okay. And while we're on this topic, and I'll just spend a minute on this because it's a little bit off topic, but it's related, I promise. There's another useful library called string. Okay, and math has all these like cool mathy things you might want to do that are all real common. But so does string have a lot of real common things that you might want to do that are string related. So it's got collections of all kinds of stuff, like all the letters, all the lowercase letters, okay, digits, hex digits, octal digits, punctuation. Punctuation is a really useful one. So if you ever have to search for punctuation marks, who can remember them all? So you can just say string.punctuation, and you can get all the punctuation marks. And you can do something like string dot uppercase ASCII, and you can get all the uppercase letters. So the main message here is, if you have something really, really super common, like pi, I mean, pi is everywhere in math. Or if you have punctuation, punctuation is everywhere in text. There's probably an easy Python library to get to. So you can be complete. And if you are working on a project and your project involves screening out punctuation, you could think of your own list, and you could look at your keyboard and, you know, maybe find all the punctuation and maybe miss one or two. But your colleagues are going to be faced with the task of checking you. Do you have them all? But if you just use a library function, they don't have to. Same thing with pi. You know, if I had this in a piece of code, you know, my colleagues might or might not agree that's close enough. They'd have to look at it and see if I made a mistake. They might or might not remember what the 6th digit is. But if I just use math.py, there's not a question. Okay, so two good libraries, math and string, to know about. You import them, and then you can use them. Just that easy. Okay. So here's the official solution. The official solution used the power. Though, as you saw, you didn't have to. Okay. And they got something pretty close to the right result. Okay. Now, here's another one. Just play with this one. See if you can guess, before you type it in, what 11 modulo 2 is going to give you. Okay, and then type it in and see if you're right. And then type in this second one. This is a topic we haven't discussed just yet. And see if it produces what you think. So if you typed in 11 modulo 2, what you're looking for is the remainder if you do this division. If you just pretend it's a slash for a minute, okay, 11 divided by 2 is going to be 5 with a remainder of 1. So the modulo is going to return that remainder. Okay. And as this says, you can use a modulo 2 operation to figure out whether that number is even or odd. And the other thing is you can use parentheses. I'm just going to move this off and play with that just for a moment. Okay, so any computer language or any mathematical system is going to have some precedence of operation for all the operators you could have, right? So you got plus and you got minus, and then you got the unary minus, and you've got star and slash, double slash. Anyway, you got all kinds of different things you can do. And how do you figure out if there's a question, which one is going to get done first? Okay, so generally speaking, the highest priority is going to be exponentiation. Okay, that's kind of on top of the heap. The next highest is going to be division-like operations and multiplication-like operations and modulus-type operations. And last is going to be addition and subtraction-like operations. Okay. Just generally, you want to look at precedence of operations for sure, because you also have things like bitwise. And I really don't know. You have bitwise operators like these that work on binary data. You know, when you have data like this, you can use these kinds of operators. I don't really know where they fit in. So in this particular example, we've got 4 times 5 divided by 2. Okay, so if you just typed in this, what would that evaluate to? Are we going to go left to right and say that's 20 and then divided by 2? Are we going to say 5 divided by 2 and get 2.5 and multiply it by 4? How's that going to work? And I'm not sure. You know, if I had to do it, I would probably drop in another. I'm a great believer in asking Python, right? It's like, dude, what are you thinking about? And it'll tell me. So 5 divided by 2, that's going to give us what? 2.5. And if we say 2.5 times 4, 2.5 times 4, that should give us about 12, right? How about 10? Okay. See, and 4 times 5 divided by 2, that would give us about 10. So it looks to me like this isn't going to matter very much. Let's see what it gives. It gives us 10. All right, so it doesn't matter. And the reason it doesn't matter is that multiplication and division are really the same operation, right? They're kind of inverted. And it doesn't matter what operation. It's got something called the commutative property. If you remember that from math theory. So it doesn't matter. But where it starts to matter is, what if you had something like 4 plus 2 times 3 minus 6 modulus 3. Now, what the hell are you going to do with that? Who knows? So I'm thinking what's going to happen, my guess is going to be that this is going to happen first. So that's going to evaluate to 2. And then this is going to happen second. This is going to be 6. So 4 plus 6 minus 2 would be my guess. So that'd be what, 8? 10. 4 plus 6 minus 2. Okay. So hang on. So I would say 6 plus 4 is 10 minus, oh wait, this doesn't have a remainder, so minus 0, right? So it would do 10. But the point is, this is a terrible equation. Why? Because you have to guess. So you want to use parens if you have any kind of ambiguity at all. So up here, it doesn't matter, but for clarity, if 4 and 5 are like meaningful, like this is the height and the width of a rectangle, and you're going to divide it by 2 to figure out, you know, what half of it would be. Well, you might want to group 4 and 5 like this, just to be clear to your readers. Okay. And the same way here, you don't want to make your reader guess. So there's any question at all, throw in parentheses, as many as you need. You can't have too many. Okay. And if you group parens like this, put some spaces in here, you can do it. You can put in any number of pairs of parentheses you want to. And the way Python is going to read it is it's going to go into the innermost and it's going to evaluate that. And then it's going to feed the result as a single value to the containing parens. Okay, and this whole thing is going to feed a result to the rest. And let's make it really complete. And put a final set of parens. So if we do that, yeah, it looks kind of confusing when you look at it, but at least it's unambiguous. So it's going to go in the middle first and calculate 6. And then it's going to come to the next layer of parens, like so. And it's going to say 6 minus 6, which is going to be 0. Okay. 0 is going to be contained in these parens. Okay. 0 modulo 3, I think, is going to be 0. So if I'm right, this will evaluate to 4. Yay. But the point isn't so much whether I'm right or wrong, but do we have an unambiguous expression? The answer is yes, we have an unambiguous expression. So parens are free, they're cheap, they're easy, and they can really clarify a lot for you. Okay. Now here's a question you can answer. So try to figure out in your head what these ought to be, and then type them into your terminal and figure out what Python thinks they are. And hopefully you'll have a close agreement. And I'll give you a couple minutes to do that. Okay, does anybody want more time? Okay. So let's see. So apparently the first one's answer is 8. And I'll bet you the reason is we're saying 2 times 2 times 2. That's what 2 to the 3rd power means. So 2 times 2 is 4 times 2. Yeah, that's 8. That makes sense. See, 3 to the power of 2. That means 3 times 3. And that should be 9. And yeah. Okay, so this last one, we got A and B. Now it's in inner parentheses. Okay, so we're telling Python unequivocally, dude, what you need to do is do this operation A times B first, and then go about doing the square root. So 2 times 8 is going to be pretty close to 16. And the square root, that's the thing you multiply by itself to make the number, that's going to be 4. And yeah, it sure is. Now, it turns out the parentheses made a difference here, because if we left them off, we might have gotten this bit of it calculated first, where it would go for the square root of 8 and doubled it. And I don't know what that is. It's 2.5 or something. And then if we doubled that, we'd have somewhere around 5. And that would clearly be the wrong answer. Okay, so this is a pretty good example of how using parentheses goes a long way towards specifying what you want Python to do and disambiguating that intent. Okay, questions? All righty. Here are some, well, I'll just type these in and show them to you. They're really super good to know about. People think you're cool if you use these, by the way, because it's a shortcut. And people are into elegant shortcuts. These are what we might call compound operators. And that doesn't deserve a whole heading. So compound operators. So if you if you're like doing a loop, so you might want to say for loop variable in and let's give it a list of 1, 2, 3. Doesn't matter what we're going to loop over. We just need some iterable object, right? we might want to have some counter variable that is going to start at 0 in front of our loop. And we might want to figure out how many times are going through our loop. One way to do it is to say counter equals counter plus 1. And when we're all done with our loop, we might ask it to print counter. Well, that would sure do it. This tells us we're going through it 3 times. Because it's so simple, we can check to make sure that it did the right thing. Another way to do the same thing would be to use a compound operator plus equals. Okay. And that does exactly the same thing. And I'll prove that to you here. Okay. So this is the same as plus equals. You might want to do something else. You might want to decrement a counter. So you could say, instead of this, you could say the counter is going to get smaller by 1. Like so. That's the same as minus equal. You might want to say counter is counter. And I think you can do this. I think you can divide by something. We'll find out really quick. So counter equals counter divided by 2. Say, and this is going to be the same as div equals, and then you can say counter is counter times 3, and that'll be the same as times equals. And there's also equals counter. You can also use the modulo like this. And let's see if I'm right. And this is going to be modulo equal. So these are all going to work like so. That's going to give us 0. And let's do all these down here and see if we get the same answer. So this one is going to be minus equal. And this is going to be slash equal. And this is going to be star equal. I didn't put that in up here. Star equal. And this is going to be modulus equal. And with any luck, this won't blow up. Yes. Okay. So you can use any of these operators. And I'd recommend them. It's just a little bit less typing. It's not like a long line of code is going to yield any information or insights or ease of reading to your colleagues. In fact, you're doing everybody a favor if you do this, because there's less you have to know to learn what you need to do. Oh, there's one I forgot. I'll just show it to you. You can also say counter. You can say power. You can say counter equals counter to the power of 2. I'm not going to show you up here because it's 0 anyway. Okay. Oh yeah, there's another one I didn't show you, and that is the same as the divide by. And this will do the floor division. For you. All righty. Now, here's a question for you. Let's say we had 1 plus 3 we did a power. And we said 2 to the power of 1 star 2 slash 2 Excel. And we did a slash 2. Have a look at that and figure out whether, and I'm going to put some spaces in here like so. Yeah. Let's see if you can work it out in your head. And I'll show you the answer. I'll hit return after you do. Work it out in your head and remember that you're going to peel it like an onion from the inside out, right? So you're going to go for the innermost parenthesis, figure out what that value is. And then just pretend that it's now one value and feed it into the outer, the containing parentheses. And keep doing that till you get to the outside. Okay, anybody want more time?
It
All right.
says syntax error. I don't know why.
Say that one more time.
Syntax error, it says in my column. So.
I think the last parenthesis.
Yes.
That's the problem.
Yeah.
I typed it in wrong. Okay, hang on. This is the problem with live performance, guys. Okay.
Yeah, it's work right now.
Okay, there we go. Yeah, so we went to the inner parens, right? That's going to be 1 times 1, right? And then we're going to raise 2 to the power of 1, which should get us 2. Okay. Then we're going to say 4. Let's see how we're going to do that. I'm going to say 4 to the power of 2, which would be 16, right? And then we're going to divide that by 2 and get 8. Okay. So if you ever have anything complicated, use parentheses liberally. Bear in mind the order of operations is going to favor roughly power-like operations. And then second place, it'll go for multiplication type operations. And in last place, it'll have addition type operations. But by using parens, you can functionally force an order of the calculations and override that. Okay. Here's another chance to practice. Let's figure out the area. Let's actually figure out the hypotenuse of a right triangle. Okay. And the hypotenuse is the longest side. Okay. And some people call it C. It doesn't matter what you call it. And it's hypotenuse. Okay. And the other sides, let's call it the adjacent and the opposite side. And let's call this one B and this one A. Now, if we know that A is equal to 3 and B is equal to 4, can you figure out what C is? And I'll give you a minute to see if you can figure that out. And if it's been a while since you took trig, I'll give you a hint. It's really smart Greek dude named Pythagoras. He figured out that the hypotenuse squared is equal to the adjacent squared plus the opposite squared. So, you know, you can use numbers and variables. So H2 is a perfectly good variable name. Well, let's just say it equals none because we're just seeing if it's a good variable name. And it's happy. However, you can't turn it around. 2H is not a good variable name because it breaks Python's rules. It doesn't know whether you're trying to give it a number or what, and it'll give up probably on a name error. Now, syntax. It just can't figure out what you're meaning. So you can say H2. So I'm going to use that as hypotenuse squared. I'm going to say this equals A squared plus B squared. So it gives us 244. Now we don't really want to find the hypotenuse squared, do we? We just want to find the hypotenuse. So we want to find the square root of hypotenuse. So the square root is the 1/2 power is one way to think of it. Or yeah, that's one way to write it. So you can say in Python **0.5 to make it so. So if you wanted to say H2 to the 0.5, you could affect a square root. All right. Now, if you wanted to tighten that up just a little bit, you could make this all in one line. So you could, instead of having H2, which you really don't want, or you don't need, I'll just put these together because I think it's more readable. You could take this quantity, and this will evaluate to something. It'll return a value, but you don't have to associate a name with it. And you could take that and you could raise it to the 0.5 power, like so. And if the dogs smile, we'll get the same answer. And yay, we did. Now, I don't know, but I'm pretty sure if we wanted to take the directory of our math library, I'll bet you $1 there's a square root in here. That would be, here it is. I'll bet we could do the same thing and maybe even make it a little bit more readable by saying math times SQRT, and then the stuff in the middle where we squared the opposite and adjacent sides. And yeah, we got the same answer. So you got a few ways to solve it. You might decide that this way, solving H2 first might be the best solution. And you might think that's the best solution because you're implementing the Pythagorean theorem very clearly. So your users can see that you're calculating the square of the hypotenuse, and then you're performing a separate operation to get the square root of it. And that would be completely legit. You might decide to make it really succinct, like so, make it one line of code. And that assumes that your readers are going to be able to understand that line of code and see it for what it is. And maybe you don't need a name like hypotenuse or hypotenuse squared with it, then that's legitimate. Okay. Or you might want to use a command like this, and you might decide that's a little bit more readable than doing a ** 0.5, especially if your audience doesn't know that a fractional power like this means a square root. Anyway, lots of solutions, and totally your decision on how you would want to implement it. Anybody have questions? Okay, well, we're up to the time for another break. So let's take a few minutes off, get back together in about 15 minutes. And if you get back a little early, see if you can find the notebook that I left in the Slack channel last time. And if anybody has problems finding it, I'll post it again, because that'll put it on top of the Slack stack, and you won't have to dig through it. Okay, boys and girls, welcome back once again. So does anybody have any questions about anything we've covered so far? How to solve global warming? Cure for COVID? Anything? Okay, well, just as well. I can help you out with Python, but not the other stuff so much. All right, cool. So we've gone a long way so far, talking about how to wrench Python with different flavors of arithmetic operators, and some simple ways to use the print statement in association with that. And the next and last topic is going to be playing around with the print statement and showing you how powerful it is, particularly when we're using it with some trick things we can do with a string. So let me introduce a new topic here. And this is going to be print, and a little bit more about strings. Okay, so you've seen the print statement. So we'll say Quinn is a husky. Okay, so we're able to print something. And we're able to print things like numbers along with strings. And if we had some other kind of an object, we could print another object in here. And what print is going to return is a human readable version of whatever we gave it. So in a sense, a print statement is a serializer. Okay, and what is a serializer? You're going to run into these a lot if you're working with things like web frameworks, like Django or Flask, are parts of Python's ecosystem, and you can use them to build a fully functional website. And one of the things you have to do when you're working with networks of any kind, including websites, is you have to take an object of some kind, and that could be a number, a list, or whatever, and you have to turn it into something that is network friendly. Okay, that means you can push it as a stream of information across a computer network of some kind. So by default, print statement sends something to what's called stdio. which is standard input output. And if we look at the help on print, you'll see that the file system, hang on, I got to get rid of my little boxy here. Okay, I'm sorry, it's not stdio. You'll see that the file system goes to system.standardoutput. Let me change my thing here. Got the spelling right, std out. Yeah, that's right. Okay, so what this is a stream of net-friendly info, and it goes to a device called system standard output, and you can just think of that as your terminal. Okay, or in this case, our Jupyter notebook, or it could be a command line. All right, so generally speaking, we bring things across our internal network in terms of keystrokes, and that's part of our standard input. Error messages, that's part of our standard error stream. If we send a file to another computer, or if we send a Google query into Google, what we're doing is we're turning whatever we type into a stream and sending it. And there's something on the other end that captures that stream. And streams are serial, right? Things go over one thing at a time. So the word serializer would go over as the word S, and then E, and then R, and then I, and so on, until each of the individual components of serializer made it to where it was going. Okay, so text is serialized in that an object is turned into something that can be sent into a stream over a network. Okay, if you get an object like a list, well, a list is its own dog. It's its own object within Python. It doesn't lend itself to streaming over a network, because a list has things you can do with it, like append. It's got properties like the count of the things in it, right? So this will not go over as an intact Python object. All right. Now you got to figure out some way to convert it into something network friendly. Printing is one way to do that, because what print does is it takes any kind of an object and it turns it into a character string. Now you don't need to know all that. That's just a little bit of background, but it's the easiest to use serializer you'll ever come across. And under the hood, all these objects have a method called, you guessed it, it begins with underscores, str. I mean string or stream, and this executes in response to print. Okay, so print will turn anything into a string of a bunch of characters, and it might even be non-numeric, non-alpha characters, and it can be decoded at the other end by something else. So in our case, we're typing in a string like this, and it gets interpreted by a Python interpreter as a Python list object. We might send print a stream of arguments, and it's going to turn this list object that we created into a bunch of text. Okay, so we're kind of streaming it into Python's interpreter. The interpreter is doing something, and it's putting it back out to our standard output device, which, because we're using Jupyter, happens to be our Jupyter thing. Okay, so sometimes we want to let print just do its thing, And sometimes we want to have a little more control over it. Now we've already seen we've got a little control over print. And let's get our help screen back. We saw when we looked at its signature last time that you can give it a bunch of values separated by commas. That's what this bit of the signature means. And we've got a couple of optional arguments. Okay, we've got sep and end. So sep and end are things we can tell it. Sep is what it puts in between the individual things that we print. And end is what it prints when it's all finished. If we want to stream it somewhere besides our standard output device, we can do that. So here we could say file equals, and we could give it a network connection. Or we could give it a file handler that'll handle communicating the contents of a file from our Python program onto our hard disk or our stick drive or anything else we might be using. And flush just helps us handle the process of moving stuff to a file. Okay, so we've got some control over what our print statement's going to do. So if we wanted to do something like print, and we'll just give it a few random numbers. We don't tell it anything else. It's going to take our default values for the separator and the end. Anytime you see an argument like this in the header of a method or a function, which are kind of the same thing. So anytime you see this in a function or a method, that means that you can optionally provide it. And if you provide it in this format, the name of the thing equals and then something, you can ask the function involved to handle that, however it's going to handle it. All right. And you can do the same thing with end. Now, anytime you see arguments like this, end equals or sep equals, that means they can be in any order at all. So let's try it. Let's just say we'll print the same thing. And we'll put another comma and we'll say sep equals, and we might just put the word sep in here just to tell us what we've done. Now we print this, instead of putting a space in, it's going to put a space and then sep. And if we maybe put a dash in here, it'll make it a little bit more clear. All right. We can optionally, let's copy this and let's do this twice. And as you'll expect, we'll get two copies of the same thing. Now, do the same two things again, and we can say end equals, as another argument, comma separated, end equals, and instead of having a new line, we could just make it another space, like so. So what it'll do is cram these two things together, because it put this in instead of a line break. All right, and we don't have to provide either. And if we provide one, we certainly don't have to provide both. So here we can just provide end equals, and you'll remember that the /n is a special character. It's called an escape character. Well, actually, technically speaking, this slash is the escape character. And what that tells Python is what follows this is going to be something you need to handle differently than you would normally. This has a special meaning. And it's only good for one character, right? So the next single character has a special meaning. It doesn't mean an n anymore. So together, these two characters, a slash n, mean a new line. So let's give it a few of these guys. And if we do that, we'll find a gap in between our lines of code. Okay, that gives you a certain amount of control. Okay, now related to this, I'm going to call this stupid string tricks. And they're not really that stupid, but you'll see strings showing up in a lot of different formats, and I'll just show these to you, not so much because you need to remember them, but you'll just know them if you see them. So if we've got some string, like so, this is how you've seen it, but you can have different permutations of it. Okay. And let's just copy this a few times. So if you ever see something like this with an R in front of it, that's gonna mean forget escapes. So if we had a string like this, and we put some new characters in it, like so, we would expect if we printed this, let's just print kind of the original version. So it broke this up, didn't it? It treated this as an escaped character. So we said new line. If we put an R in front of it, it wouldn't bother interpreting it. It would ignore the fact we have an escape character. Okay, so that's what an R in front of it means. We can have a U in front of it, and this is sort of, it's deprecated. But in Python 2.7, it means Unicode. All right. Now, all of Python 3 is Unicode, which means you can use Chinese characters or Turkish characters or whatever. But you'll see this sometimes, and it means we're encoding it as Unicode. If you see something like B, this means that it's a binary string. So it represents a binary number. And the one I really want you to know about is if you put an F in front of it, that means expect formatting inside. And that's optional. You don't have to. And that's an F, like so. Okay. Now if you put an F in front of a string, like so, it'll be just fine. You don't really have to do anything with it. But if you want to, you can. So if you want to put something specific inside of it, you can put in parentheses, like so. Or sorry, curly braces. All right, and that will allow you to, whoops, I didn't want to do that. This will allow you to put in arguments, like so. And instead of having to say something really cumbersome, like if you're going to do a print statement, to say some string, and then leave a space, and then say comma 1, 2, 3, and then start with a space and say something else ending with a space, and then 3, 4, 5, 5. I mean, you could do that, or you could use this formatted string and print it instead. Right, and it'll honor whatever spaces that you want to put in here. And it'll honor if you wanted to put in a new line anywhere. All right, so this is called an F string for obvious reasons. Okay, and that's just formatted. These things are actually pretty cool because here we just gave it a value. But what if we wanted to print and we put a formatted string, and let's close that string while we remember. We might want to say the value of A is, now we can put A in here and any kind of punctuation, and B is something like that. All right, and we've still got A and B in our namespace. If we don't, we can replace them, but that's gonna nicely format it. And this is really a lot more readable than doing something like the alternative. By putting the value of A here and the value of B. Oof, dang it. And the value of B. I mean, it'll get us the same place, but you can read this string really easily. And you don't have to define it just in the context of a print statement. So if you liked this, maybe you wanted to reuse it, you could say, call it FMT. Yeah, format's a keyword. So let's just call it FMT. So you can make the FMT object this particular formatted string. Now you can say print, and you just need to tell it to print format. It'll be happy. Now that's real convenient because now if you wanted to say A equals 666 and B equals 999, all you got to do is print format again, and it'll plug those. Wait. That did not work like I thought it would. Let me do this again. Yeah, okay. So that worked. Now it should work also if we change that. No, it doesn't. Okay, yeah. So you've got to define this after you define your variables. So like so, and it'll take. Okay, but the nice thing is that you don't need to muck with it. You know, you can retain this format statement without changing it. And this might be really complicated, and you don't want to type it in all the time. All right. And you can also do this. Let's just say that, let's make these floating point numbers. Let's make them kind of weird. So here you can say that want this to be, I think that'll work. No, sorry, it's 0.2f. Okay, so you notice that the A here is 111, and it's got like a bunch of stuff back here, and we can put a bunch of stuff here. Okay, now this bit after the colon formats the data reported as A. Okay, so we said .2, which means we want 2 places after the decimal. We didn't do that with B, so we just let B whatever B take as many decimal points as it wants to. And if we wanted to limit B to, I don't know, maybe 5 places after the decimal, we can do that. Okay, and actually I screwed this one up here. There we go. All right, so you can put a lot of stuff in between these curly braces, and you can make this formatted string pretty much display anything that you want to in any format. So you can substantially upgrade what you're able to do just by playing with the parameters of the print statement, like we did initially just with using sep and end. Now you don't lose anything in terms of being able to embed escape characters or anything like that, but you gain a lot in terms of being able to format. Now I don't want to belabor on this too much because I don't want to run out of time, but if you just Google Python formatting, I'd say mini formatting is probably better. Language, and I'll put this into the notebook. The first thing it'll come up with is here's string operations. There we go. That'll work. So this will get us to the documentation. Oh, and I don't know. I don't think I've shown you the documentation yet. So if you find yourself here, and this is important to remember, we've got docs.python.org. Right, so you know you're in the official Python documentation place. A cool thing is you can get the documentation in a bunch of different languages. Okay, so if you're more familiar with Chinese, you can get Chinese. One important thing is here, because here, this is all the versions of Python. Python 3.10 just got released, like maybe 2 weeks ago. They're working on Python 3.11. If you're really masochistic, you can download a copy which might have bugs and play with the latest greatest. But this documentation is specific for different versions of Python. Okay, and it'll automatically put you to the latest one. Now we're not using the latest one, but the documentation puts you there anyway. So you want to be a little careful. If you're on Stack Overflow, say, and you're trying to get some help on a problem, and it has a link to the documentation, take a minute and go to the top, because it might land you to the 2.7 documentation. Okay, and it'll yell at you up here. But if it points you to a link way down here somewhere, you're not going to know it unless you look really carefully up here. And if you start using Python 2.7 documentation, particularly on strings, you can waste a lot of time. So always make sure that you got 3 point something, or whatever you're using. All right, it's not going to much matter for what we're doing, which one we pick, but we'll pick this just for the heck of it. Okay, now where I was going with that is you can get into the format specification language, right, and template strings. All right, and it gives you all kinds of things you can do to do string formatting with templates. If we go back, you can get into format specification, and there's a lot here. But there is, where am I going? Yeah, there's ways to do alignment of the different things in your print statement by way of formatting your string. There's a way to pad things out. There's a way to do alignment like you can make like 3 or 4 columns of specific widths and tell it everything in that column is going to be left justified or right justified or centered. I forget what equal means. You can tell it whether to put signs in front of your numbers. Anyway, you get the idea. And if you scroll down, all the stuff in this green box is going to be explained. So it's got ways to automatically convert stuff to binary numbers or hex numbers, you know, and all that. So I wouldn't read this, just know it's here. And it goes into, you know, really, really, really a lot of detail. But suffice it to say, you can use all these formatting tricks and techniques within the curly braces of a print statement. Okay, or sorry, within the curly braces within a string, which then you can go ahead and print. So strings and print are really joined at the hip. They're really closely related because, and that's where we started, the print statement is fundamentally a serialization operation, and it converts objects to strings to get them to your standard output device, which is precisely the same operation you need to perform on any kind of an object to send it anywhere. Now, there's different means of serialization. Print isn't the only one. And there's a lot of them. And there's a lot that are optimized for specific complex Python operations. Like there's one called pickle, for instance. So you can take a really complicated Python program using really complicated objects, and it'll turn it into a serialized object that can get completely rebuilt as the same Python object on somebody else's machine after first having gone through a process of serializing it, just like a print statement does, and then reconstructing it from that serialized form on the other side. So, let's see, what else do you need to know? Okay, so you need to know what these mean. The one you really need to do something with is the format. You've seen some things you can do with the format, like you can plug in specific values and you can plug in variables, and you can apply appropriate formatting to those variables to include formatting numbers and formatting columns and formatting alignment and padding and stuff like that. All right, any questions? Okay, now there is absolutely nothing wrong with putting together a bunch of operations within a print statement. Okay, so there's an example I can show you. If we just had a piece of text and we can say, I bought, and we can make another thing called text2, and it can say kilos of apples. You can do things like print text1, then you can print some other object, doesn't matter what it is, and text2, and that'll give you just what you think. So this is a reasonable way of formatting stuff. One thing I should draw your attention to is the print statement doesn't need you to do any kind of typecasting in order to make it work. Okay, so here we had a text object and we had an integer object and another text object, and print was fine handling all those. just as print is completely fine handling like a list. Hey, Junior, do you have a question, sir?
Yes, I do. So for that example that you just did in line 125, does it matter if you put a comma or semicolon, just like after text one, you put a comma instead of a semicolon? So do you use semicolon only in when you use the format? When you use the format or not?
Let's see. You can use a colon. This is called a colon. And if you can use that in one of these fields that are enclosed by curly braces like that, you can, but you don't have to.
I'm sorry. No, I'm referring to whether, for instance, where you have in line 125 print text 1, you put a comma. So between the comma, or could you have used a semicolon instead of a comma after text 1, 888 and comma text 2? Could you have used a semicolon instead of a comma?
Okay, that's a really good question. And yeah, so let's say use of semicolon. Okay, so the short answer to your question is you can use a semicolon as a line separator. Okay, so if you wanted to say A equals 777, B equals 888, or C equals 888, I guess, and Z equals 789. You can do that. And this will give you values of A, C, and Z. All right, but this is not PEP 8. So it's syntactically correct, but it's considered bad manners. Now, where you'll see this sometimes is and I've done it sometimes too. If you're presenting a paper at a conference and it's to a bunch of geeks and you're expected to show code that works, but you've only got a certain amount of area on your slide. You know, I've done this just to squeeze it in, but it's considered something you shouldn't do. The semicolon up here is just part of a string. It's just another character. It doesn't matter for syntax. If we put in semicolons here in our print statement, we would run into disaster, because Python's gonna get here and not quite know what to do with it. Right, so it just throws up its hands and says, "Dude, I'm not even going to try." Okay, so you want to, whenever you're separating arguments in a call to a function or in the declaration of a function, the separator is always going to be a comma. Did that answer your question?
Yes, perfectly. Thank you.
Okay, cool. Now, sometimes you'll see a semicolon used at the end of a line. Like there's some things that, like when you get into visualization and you start using Matplotlib and pandas and stuff like that, there's a bunch of things you can do in terms of like plotting something. And this isn't going to be correct syntax. So just like you're going to do some operations, then you're going to plot something. And sometimes you got to trick Jupyter notebooks into actually displaying the thing. And I haven't cracked the code on when that happens. So a lot of times you'll see stuff written for notebooks that does graphics, and you'll see a semicolon after a line like that, where you really don't think that you should have to, or something like that. But sometimes I think it's used to trick Jupyter notebooks into showing you a picture of something. Now, if you ever see a bunch of code like this, and you will on occasion, you know the person started out life learning Java or C or something like that, and they can't break themselves of the habit of putting a semicolon at the end. It doesn't hurt anything. It's just kind of cute. They'll lose that habit eventually. Okay. See, let me put in a few here. We'll keep that at the end. Yeah, the point I was going to make here is that the Python does whatever typecasting it needs to do to convert these various objects into something like text. All right, and if you wanted to do this without print, if you just wanted to do it on your own, and you wanted to say something like text1 plus text2, you could do that because you're going to get a concatenation operator. Okay, but if you wanted to try to do what we had in the print statement, and we said text1 plus text plus 888 plus text2, we'll run into that same kind of problem we saw earlier, where we got a type error because a string doesn't know how to use a plus sign with a number together, and vice versa. A number doesn't know how to use a plus sign with a piece of text. So you have to use a typecast operation like this. And if everybody's a string, everybody is happy. Okay. And let me put the original in there, just so it'll show up on your notes as suffering a miserable death. There we go. Okay. Oh yeah. Last thing, I think probably the last thing I want to show you is, so if we have let's make a formatted string. And we've seen that we can have, we can say 1, and we can put in some tab characters here using the /t as an escape. And then we could tell it we want a new line with a /n character. And we could continue and say a 2 and 3. We can put in another new line character and a 4. And we can print that thing. So we get something pretty sensible. So you can use a /t and a /n, but check this out. And I didn't even know this existed until I was looking over these class notes. There's another escape character called /b. And check out what happens. So we got a 1 and a 2 and a 3 and a 4. And look, we lost the UR. And actually, let me do this so you can see it before and after. So keep your eye on the last line. And now when we have these 2 /b's, you can actually backspace over something that you already printed. Now, why you would want to do that, I don't know. I mean, the only use case I could possibly think of is maybe if you wanted to print something like password is password 1, like so. And then you might want to say end is nothing. It's like an empty string. And then you could, I suppose, go print backspace. I don't even know whether that would work. Yeah, that, oh wait, maybe, yeah, maybe that worked. Let's put in a bunch more. Anyway, it's possible to backspace. Like so, okay, and that is eventually getting rid of our password. Anyway, you can do it. I don't know why you'd want to do it, but there you have there you have it. And that's all I have for you guys today. So, are there any questions? Okay, I told you today would be easy, right? I didn't lie to you. So we talked about some operators, some compound operators. We played around with using them. We played around with using parens to force order of operations. We solved a couple geometry problems, and we learned some cool things about print. Piece of cake. So what I'll do here is I'm going to save this thing, and I'm going to paste it into the Slack channel. It's going to show up as class notes, intro to Python 3. And you should be good to go. So I want to thank all of you for showing up tonight. And I hope you learned something. I've had a good time, and I'm looking forward to seeing you next time.